Hello, I'm going to show here briefly how to synchronize patch blocks with other equipment through these triggers. In this case I'm going to show this here with a Korg Volca, using the trigger out and plug into the audio input of a patch block and just get those two synchronized. So first off, let's have a look at what this machine actually spits out. Therefore, we're using an oscilloscope, which is a quite handy tool for this. I plug the ground here to the sleeve and a tip to this guy here, and let's have a look at that. Now you can see this is how our trigger looks like, what we get out of our Korg machine, which is, what's that, 5 volts, like a nice sort of 5-volt spike, and the rest is just 0 volts. So this should be quite easy to use in our patch block, just listening to the audio input and using a transition from 0 volt to a positive voltage to trigger, for example, an envelope, or as it is a regular trigger. If I increase the speed here a bit, you can see if it's slower, less triggers, if it's faster, more triggers. I could use that train of triggers straight to trigger a sequence. So in the software, I've built a little test patch, which is quite simple. We take the audio input. Well, one thing I found out, unfortunately, what happens to the signal here once it comes at the audio input, it's inverted. And once it goes to the audio output, it gets inverted again. So if you take the audio input and route it straight to the audio output, it's the same signal than what you send in. Unfortunately, between those, it's upside down. So in order to get this into the right orientation, we can just multiply it with -1. So audio input goes through a multiplication by -1, that's the right way. Now, sometimes because this is some analog signal, doesn't necessarily mean that it's exactly 0, so it could be a bit above. If we use that as a trigger, then it's not really a transition from 0 to a positive value if it's like 0.01 or something. So just to make sure that it is negative and then goes into a positive range, we need to subtract the signal or subtract something from the signal. So shifting the whole signal down. In this case, I just used the left knob here to change that value by how much I shift that signal up and down. And what we then get here is a signal that is very likely negative, and at some point, whenever it gets this trigger from the Volca, goes into a positive range. I can use that here for the line envelope as a trigger signal, which I then multiply with noise, and we get some kind of percussive sound, which should be synchronized with the clicks we get from the Volca. So I've put that sound on this machine here. Maybe let's listen to how that trigger sounds first. Listen here. Okay. Now plug this in here and use this. Okay, this is turned on. Now we don't hear anything, even though we get our trigger in here and our percussive sound out there. The reason is this knob is all the way down, which is how much we subtract this, how much we shift this signal down. If I move this up, there we go. Now we can hear a sort of noisy, kind of percussive sound from our patch block based on the triggers from here. Now in another patch, the sync input here, I also put them, the code for these in the description of the YouTube video. I just kicked the camera, damn it. Into the YouTube video, so that you can copy and paste the code from the YouTube description straight into your Patchblocks editor and just play around with it. Same principle again, audio input, then multiplying it by -1. Maybe we change that in a future version just to make it a bit more intuitive. I think I left that out originally to save some calculations, really, because that's how the hardware produces it and the hardware reads it, like the level shifter, and here on the output side on the hardware the signal gets inverted. So again, -1, then subtracting a bit of some kind of value, in this case 0.2, and I use this here to step through a sequence in a pattern. And I've got two buttons here. The first one lets me select the pattern. The second one lets me select some kind of root node on which the pattern is based. This goes into MIDI 2 cycles per second, just straight into a saw wave oscillator through a filter. Can crank my filter up to 4000 Hertz as the cutoff frequency, and then the resonance is plugged in straight from there. Goes to the audio output. That's it. So no crazy fancy magic there, just a few sequences. I've got this here in this block. So now let's change this. There you go. Turn it on. So that's pretty much it. So check out the code in the description, and I hope you enjoy syncing those two machines. Thank you.